Hello, Assalamualaikum, and very good day. Today I will present you the topic of our week 4 lecture, and hope you listen and understand what I'm going to present you in this video. So we go to the right now we are still in compressible flow, and we will go into a new topic. So this is the content for the week 3 and week 4 lecture. We have learned about stagnation properties, sound wave, speed of sound, and Mach number. And also we have learned about one-dimensional isentropic flow, fundamental equations for isentropic flow, and compressible flow through nozzle. So we have incompressible and also compressible. So now we are going to learn about Rayleigh and Fano flow in duct, and also shockwave, either normal or oblique, and also expansion wave, Brandt-Meyer. Now for this week's this week lecture objective is to predict the occurrence of shock and calculate the property changes across a shock wave. So we will learn about what happened during shock wave, and we also want to understand the effect of friction and heat transfer on compressible flows. Now we go to shock wave. There are two things that we are going to consider that happen when there is something or some disturbance or abrupt change in fluid flow, which cause there are two phenomena, which is the first one is shock wave and the second one is expansion waves. So sound waves are created by small pressure disturbance and travel at the speed of sound. So that is sound wave. And for some back pressure is the pressure that against the flow. Due to the back pressure, abrupt change in fluid property occur in a very thin section of a converging and diverging nozzle. So remember, this converging and diverging nozzle is to create supersonic flow with supersonic speed. And due to this due to the abrupt change. So remember, the word is abrupt right here, abrupt change. It will create a shock wave. So we will study the condition under which shock waves develop and how they affect the flow. There are two types of shock wave. The first one is normal, and the another one is oblique. So normal one is much simpler compared to the oblique. Actually, there's another one which is bow-shaped shock wave, but that one we will not cover it in this lecture. But we will learn, we will know about that after this in the following slide. And we will also learn about expansion waves according to the Brandt-Meyer principle. Okay, this is shock wave, but we will not learn about this shock wave. So this is just for decoration of my slide. But it's a nice model. Now we will want to see what is shock wave and what happened when shock wave appear. So we'll go to video. So this is the video. You just look at the rocket and what happened to the rocket, and what caused the shock wave. Record this video, and suddenly, so that is what happened when shock wave appear. Okay, now we go back to the slide. So we don't want shock wave to happen, and actually it's like a phenomenon that we want to avoid, but because of some circumstance, we need to consider it because it's unavoidable. Now, we will learn first of all, we will learn about normal shock. Just like I said before, there's normal shock and there's another one is oblique shock. So normal shock wave appear in a plane normal to the direction of flow. If you look at here, the red wave, that is the shock wave, where it's perpendicular to the flow. So what happened when shock wave appear? So if you look at here, there is a property of velocity, pressure, enthalpy, density, and also entropy. It will change after the shock wave. And if you look at here, the Mach number is bigger than 1. And what happened after the shock wave? The Mach number reduced into below than 1. What does it mean? It means that the velocity initially is in supersonic speed. When the shock wave happened, the flow become slower, lower than the sonic speed, which is subsonic speed. So that's what made what the effect of the shock wave. It will reduce the speed of the flow and other stuff also. These parameters will also change. So flow process through the shock wave is highly irreversible and cannot be approximated as being asentropic. So if you look at here, the entropy also change. We cannot consider it as asentropic process because there are so many disturbance and highly irreversible. Therefore, we need to consider the change of entropy. So develop the relationship for flow properties before and after the shock using conservation of mass, momentum, and energy. So we want to develop the relationship between the properties of the flow before and after the shock wave. So this is the duct or the maybe a pipe with an increasing radius, and this is the shock wave. And what happened? The properties is different compared to the previous one and the